Imagine testing your trading bot live against mainnet data, performing swaps using Jupiter and getting price updates via Pyth, all while using unlimited free Devnet SOL locally on your computer. No fake mints, no cloning and importing into your local cluster, and no surprises when you're going to production. My name is Benjamin, and in today's video we are going to build and test a simple trading bot that will swap Solana against USDC using the Jupiter v6 swap API and getting price updates via Pyth, all in a realistic local development environment using Surfpool. So in today's video we are going to cover what Surfpool is and why it's a great tool compared to the classic Solana test validator or Devnet, how to build a simple trading bot using Jupiter and Pyth price updates, and how to swap fake SOL while pulling in real mainnet states and data. And on top of that, all the code will be available for download via our GitHub repository. By the end of this video you will have all the tools to test your strategies with mainnet level accuracy while benefiting from local development practices. If you want more information, you can always check out our official documentation or join our great Discord community. Both links will be in the description, and with that said, let's get started. Alright, so before we dive into the code, let's have a quick look at what we're actually going to build. So first we are going to create a simple trading bot that fetches the latest SOL versus USDC price, let's say every few seconds, and it feeds that into some basic trading logic. Now that logic is going to decide whether we are going to buy or sell, meaning are we going to buy SOL with USDC or sell SOL for USDC. The price data comes straight from the Pyth price oracle, which is in my opinion the go-to standard for real-time prices on Solana, and you can think of Pyth as a super fast, reliable price ticker that delivers live market data directly on-chain, like for example the SOL versus USDC price. Now we're going to fetch that price using the well-known custody price account, and for this we are going to use the Solana RPC method, get account info. Now to run everything locally and realistically, of course, we are going to connect our bot to a Surfpool local validator, and Surfpool is basically the upgraded modern alternative for the classic Solana test validator, and this is also mentioned within the official Solana docs. Now it's a drop-in replacement that gives us a lot of power and also extra great features, and it's a good alternative for Devnet. Now Surfpool has a lot of features, as I said. However, one of the greatest features is lazy forking, and that means when our bot or a transaction bidder needs something from mainnet, like for example the Jupiter program accounts, Radium pools, Pyth oracles, or the USDC mint information, Surfpool automatically pulls the latest live state from mainnet using a connected RPC, and it does that just in time. So there is no mainnet forking, no manual cloning, no huge downloads, and we don't have to create fake USDC like mints to just start testing our bots. We can get mainnet realism using our local cluster on our local machine. And on top of that, Surfpool has also great features like for example cheat codes for mutating accounts on the fly. There is time traveling that we can do, transaction inspection, and it has a local web dashboard that we can use to inspect everything that is happening within our local cluster. Now finally, to test under different market conditions, we can use something called the scenario builder, and we can use that to manipulate the SOL price which is coming from that Pyth feed, simulating pumps, dumps, or whatever swings that we actually want to test with our bot. So we're going to do that of course with fake Solana, Devnet Solana, or local cluster Solana, whatever you want to call it. And in the background we are going to have real mainnet data and programs that we can use and rely on. And of course we are going to have control over the price that we feed into our trading bot. So it's the perfect setup for realistic bot testing in my opinion, without the risk of losing real funds, and we don't have to code these price changes into our code base. So with that said, let's jump into the code and let's have a look at how we can set this up. Alright, so this is our code base for today, and the first thing that we can do is make sure that our local validator is running using Surfpool. Now if you don't have Surfpool installed, what you can do is go to the Solana documentation, and then under installation you will see Surfpool CLI basics, and there you will find all the information on how to start Surfpool and also how to install it. So if you click on the Surfpool documentation link, you will go to the official website, and then under installation you can find back all the instructions. Now if you're running Mac OS or Linux, it's quite straightforward. However, if you're running Windows, such as I am, you will have to install the Windows subsystem for Linux, which you can then use to install Surfpool. Now, once you have both installed the Windows subsystem for Linux and Surfpool, what you can do is open your terminal and then click New Terminal. And here I can type WSL. As you can see, this will start my Windows subsystem for Linux, meaning that I have access to a Ubuntu machine. So if I type here now etc, for example, OS release, you can see I have now this Ubuntu machine that I can use to run Surfpool on top. So if I type here now Surfpool start, this will start Surfpool for me and also that local validator on my local machine. As you can see, you are greeted by this terminal user interface, and they also have this studio. So if you click on this link here, you will go to Surfpool Studio, where we can inspect whatever is happening within our local cluster. And there are also additional features like the faucet and the scenario builder, and we are going to look at that later on. Now on the right hand side, you can see here that we now have this RPC and this WebSocket URL, and these are our endpoints that our bot will use to communicate with our local cluster. Now you can also see source here, and for now this is pointing to the Mainnet RPC URL, which our local cluster can use to interact or sync with Mainnet in case it needs to do so, to fetch these account states, to fetch these programs from Mainnet. Now as you can see, this is pointing to the default Solana RPC endpoint within Mainnet. However, we can also change this, and if we want to, for example, connect to our own RPC endpoint from SVS, we can do so. Imagine you are testing a bot that requires higher rate limits, then you can also update this, and I will show you how that is done. So if we go back to our code base, what we can do is just stop this, and if we type Surfpool start like this, I believe, and then we specify the RPC URL flag, we can provide our own URL here. And as you can see, this one is pointing to a staked RPC node within Amsterdam. And also if I type now enter, you can see that also our local validators start up again. And if we go back to the actual studio, you can see that now the source is no longer pointing to that default URL, but it is pointing to our own staked RPC endpoint. So that is one way that you can set that up as well. If you require higher rate limits and you want your local cluster to communicate with your own RPC URL, you can also do that. Alright, so now that our local cluster is running and we can access the Surfpool Studio and we are connected to our personal RPC endpoint, let's have a look at the actual code. Alright, so our local validator is running and we can close this here now. As long as it is running in the background, we are fine. Now if we look at the package.json file, you will see that if we run npm run dev, this points to the index.ts file. So let's have a look at that file. Now what you can see here is some functions that we will use for our trading bot. But if we scroll down all the way, the first thing that we are going to trigger is the restore wallet function. Now if you have a look at that real quick, what we do here is just derive a key pair using key pair bytes. And these key pair bytes are just a private key that we use to derive a new wallet from. And then we store that into a wallet variable that we have declared here on top. And that wallet we can use to then sign transactions within our bot. As you can see here, we have that private key, but if you want to recreate one, you can always go to Surfpool Studio, because here they have that faucet. And what you see here is that we can airdrop Solana into a wallet, and we can also create a wallet. Now if we do that, if we click on this icon here, it will generate a wallet for us, and we can say that we want to airdrop 10 Solana into that wallet. Now besides Solana, what we can do is choose to also airdrop another mint into that wallet. And if we click on Solana here, you can see that we can choose for USDC, USDT, Ray, or JUP. We can even search for tokens like, for example, Trump. So we can airdrop these tokens straight into our wallet from this faucet. Now for now, we are going to choose USDC, and we are going to say that we want 1000 USDC within that wallet. And if we then click on this icon here, you'll see that our wallet is now created. What we can do now is download that key pair, and if you click on this button, it will download that key pair straight to your local computer. And you can also see that we now have this wallet here, and this is the public address, and we have SOL airdropped into that wallet, and we also have USDC airdropped into that wallet. What you can do is take this private key here. So if you open that file, you will see that this contains a private key, and you can just copy all its contents, and then you can paste them here within our bot. So that's what we're doing now. So we paste that here, and then we are going to use that private key for the wallet that we just created, because we know this wallet has now 10 SOL and 1000 USDC. Now if you go back to Surfpool Studio real quick, as I said, you can see here we have that SOL and that USDC, and if we click on this icon here, we are going to the Explorer, and also here we can see that we now have 10 SOL, and under tokens we now have this USDC coin here which has 1000. So we have 1000 USDC. And this is the wallet that we are going to use in our trading bot to swap SOL for USDC, and of course USDC back to SOL. Alright, so now that we have our wallet and we know that it has some SOL in it and also USDC, we can continue. And you saw it was really easy to airdrop these mints and that Solana into that wallet. We don't have to recreate any USDC like tokens within our local cluster. We can just use the faucet from Surfpool to airdrop these tokens straight into our wallet that we created. Now the next thing that we are going to do is initiate a connection, and that connection is just created using the connection class that comes with the Solana Web3 GS package, and here we specify our local RPC endpoints. So if you look at Surfpool Studio, here you can see the RPC URL. You can even copy it, and that is what we use here to create that connection. We are not using our own RPC from SVS. We're actually using the local validator's RPC endpoints that are exposed to create that connection, and then we store that connection here in that connection variable that we can use in the remainder of our bot. Alright, so now that we have created a wallet and a valid connection, the next thing that we are going to do is create an instance from the Jupiter class. And as you can see here, we have a function called init Jupiter, and this creates an instance from Jupiter swap class. And that class lives here within the Jupiter.ts file. Now this class holds all the logic for us to swap using Jupiter. As you can see here, we have a function getQuote where we will actually fetch a quote from Jupiter, and then we are going to use that quote to create swap instructions, and then we can use these swap instructions to actually make a swap where we will sell SOL or buy SOL. And you can also see here the actual swap function. It will take that information, it will take these instructions that we created using the getQuote and the getSwap instruction, and we're going to send that off to the actual connection that was created using our local validator. And the great thing is, once we switch our bot and we connect it to, let's say, Mainnet instead of our local validator, we don't have to make any changes to this class at all. It can just function or on Mainnet or on our local cluster. And that's the great thing about using this kind of setup. So we will come back to this class later once we're actually going to swap the tokens. But for now, you can just remember that we use this Jupiter class here that we created and store in the Jupiter swap variable to do the actual swap on our local validator. Alright, so now that we have a wallet, a connection, and a instance of a class that we can use to swap USDC for SOL or SOL for USDC, the next thing that we are going to initialize is our trader class. And as you can see here, I have this init trader function that is also triggered here. And what that does is creating a new instance from the trader class. And trader class is specified here in trader.ts. Now this class holds all the logic to send us back signals. So it can send back a signal like buy or sell or do nothing, and it will also keep track of the prices that we feed into this class or the instance of that class. Now the logic for this strategy is quite straightforward, and it's not about the trading strategy itself. And what we are going to do here is, once the price goes up with 10% from the last price, we are going to sell SOL, and if it goes down by 10% from the last price, we are going to buy SOL. And this class will keep track of the prices that we feed into it. It will also do the calculations, see if there is a 10% increase or decrease, and then send back the signal to us. And that's why we created that instance here from that trader class, because we can store it in trader, and then we can use that instance to send the prices to, and that will also keep track of the price and send us back a buy or sell signal or do nothing signal. Alright, so now that we have a wallet, a valid connection, we have a class to swap SOL versus USDC and back, and we have our trader logic, which holds our strategy and will send back to us buy or sell signals. Now the next thing that we need to do is fetch the price from USDC versus SOL, and then based on that SOL we can actually trigger a buy or sell action. Now we have that function here called fetch account info, and if you look at that function, which is also triggered here eventually once everything was initiated successfully, you can see that every X amount of seconds, so we set that interval here and we repeat it every 1000 milliseconds, which means every second we are going to trigger this logic. And what we are going to do here is use our connection that we created earlier, and we are going to use the function get parsed account info, and this method is exposed by the connection that we created earlier. Now what we are going to do is fetch the account info for a certain account, and the account is specified here. So let's have a look at that account real quick. So the account that we are going to fetch the data from is called the Pitnet Custody Price SOL account. And what this account does, it provides us data that includes the Solana current price. As you can see here, the price message, it has data, and that data has a price object. And here you can see the actual price of Solana. Now we can also look at Postman. So what we can do here is use the RPC method get account info. It's the exact same method that we are using via our connection. However, this time we are going to do a API call to our local validator using this RPC method here called get account info, and we're going to fetch the account info from that account here, the same exact account. So if you click send, you can see that we get back a response which includes that price message that we just looked at and also the price. So as you can see here, this is the price, and we have an exponent of -8, which means that we have 8 decimals. So the price of Solana is currently $142, and that is what we are going to fetch every X amount of seconds. Now if you go back to the official documentation from Pit Network, you can see under push feeds and then Solana, there are many other accounts that also provides us the prices. For example, SOL versus USD, we have also Bonk versus USD, you also have Bitcoin versus USD. However, we are interested in the price SOL versus USD because our bot is swapping SOL versus USDC and USDC back to SOL. So this is the account that we are going to use to fetch the price every X amount of seconds, and then we are going to take that price, feed it into our trader logic, and that will send back to us a buy or a sell signal. Alright, so that's exactly what we do here. We are taking that account info that comes back from that call that we do here, the get parsed account info, and from that account info we can take the price message. So if we look back at our call real quick, you see here that price message, it includes things like the actual price, the confidence, also the exponent, and some other values. And these values we are going to store in that object here called pit data. Now we're going to take that object and send it to a helper function that we have declared here on top, and that helper function, it doesn't do more than just take that data and return to us the price in a human readable way, like it says here 150, the example, so we don't see that big string. We also get the confidence score back and also a formatted string including the price and that confidence so that we can output it in our console. So it doesn't do more than that, it just takes that information and returns to us in a nice way. Now from that response from this helper function, we are going to extract the price and the formatted string, and then the formatted string we can output in the console. That's what we do here. So the account info was received at this time, and then we output the price, and the actual price that we calculated here, that we are going to send to our trader. Remember, we created an instance from that trader class that we did here, and we stored it in trader, and that's what we do here now. So we're going to update the price, or we're going to send the price. Now our trader, as I said earlier, is going to send us back a signal, and that signal will be buy or sell. Now based on this signal, if it is buy, we are going to buy SOL, and if it is sell, we are going to sell SOL using our Jupiter swap instance that we created earlier. So before we are going to look at that, let's start our bot and see if we can actually get a price back every second. And to do that, we can go to terminal, new terminal, and here we can type npm run dev, just like that. And then our bot will start, and here you can see that we get this Solana versus USDC price back every second. Now, this is really great and it seems that our bot is working. However, it's not ideal if we want to test our logic, if we want to have these price swings, because the chance of Solana price going up 10% and then again down 10% is really slim. And in order to simulate that, these price changes, we can use Surfpool Studio and better the scenario builder actually to manipulate the price that comes back from our Pyth account, and that's what we are going to do now. So what we can do is just close this terminal real quick and then we can go back to our code. And for now, what we are going to do is just comment this out, so we don't want it to buy or sell. We're just going to fetch the actual price, and we are also going to manipulate the price that comes back from this call here. And in order to do that, we can go to Surfpool Studio, and here you will see something called scenarios. And here we can create new scenarios. We can click on that plus sign here, and we can create a new scenario. Now you can give your scenario a name and also a description, but more important, if you click on scenario, you can add blocks, and if you click on a block, you can also add a integration here. And for now, we are going to use the Pyth integration, as you can see here, as we are fetching the price from the Pyth account. Now if you scroll down a bit, you will see here override SOL versus USDC price feed, and that's exactly what you're going to do, because this is going to override that price from that data that we pull from the Pyth account. So as you can see here, it already fetches, and also here it says 142, so this is correct. However, what we are going to do, we are going to say that the price is going to be 100, and then we can also add that. As you can see here now, the first next slot will have the price set to 100, and what we can do then is add an additional slot here, and again we can override that price, and this time we are going to set 180 for example, and also that we can set. So now we have a swing from 140 to 100 and back to 180, and we can add an additional one, and here we can say that the price will be not 180, but this time it's going to be 200, and then we can also add that, and you can add as many slots as you want, and I will add a few more, and once that's done I will come back. Alright, so as you can see now, I added a few slots, and this will just simulate these price swings. So we're going up, down, up, down, up, down, down, for example. And then because we are simulating this price, if we click here now this play button, you can see that it starts simulating the price. So if we now go to Postman real quick and we do that same call here, you can see that the price is now 180. So it's no longer that 140, but it is the 180 that we are simulating here. Now if we are going back to our bot, what we can do is start that up as well, and if you type npm run dev just like this, you will see that it starts querying that price. And now as you can see, our simulated price for Solana is set to 180. It's no longer the 140. Now what we can do now is go back to the scenario builder, and if we go to the next step, you will see that that price is now also been updated. So if we go back to our bot, you can see the price rose by 11% because it is now $200. If we go back, we can do that once again, and as you can see, back to our bot, it also updated the price here. So now the price changed only 9%, so we're not doing anything. It's smaller than that 10% that we're looking for. However, we can see that the price went from 200 to 220. So what we can do now is just go back to the scenario builder, and we can step through these steps. So every second the price will be updated. Our bot is fetching these prices, as you can see here, because we are clicking through all these updated prices just step by step. And if we go back to our bot, you will see that it fetches here these price changes. So it sends us a sell signal because it went to 300. It sends us another sell signal because it went to 500. Then it dropped to 90. So it says you need to buy. There was a drop of minus 81%, and eventually it says us to sell because we gained 1000%, because now Solana is at 1000 USDC. And that's how we can actually simulate that price that comes through in our bot via the call that we are doing here. And we don't have to code these price changes into our bot. We can just simulate that price using Surfpool, as you can see here, using the scenario builder. Alright, so now that we know that we can fetch the price and also manipulate the price, the next thing I did is uncomment the buy and sell here. And we're going to swap SOL for USDC and back using our Jupiter swap instance that we created. And this is also a really good use case for Surfpool, as these quotes that we are going to fetch and the instructions that we are going to build using these quotes, many of the accounts and the Jupiter V6 swap program lives on Mainnet. However, Surfpool will be able to fetch these states that live on Mainnet and all the data from Mainnet and then make it available within our local cluster. And that's what we are going to check out now. So once that price comes through and we get a buy and sell signal, we are going to swap using the Jupiter swap clause. We are going to get that quote, create the instructions, and then we are going to sign that transaction with our local wallet that we created earlier that holds our USDC and SOL. And then we are going to send that transaction to our local validator, and you will see that these balances within our local wallet are going to change. So that's what we're going to do now. So if we open our terminal once again and we type npm run dev, that starts our bot again and it will start fetching that price, as you can see here. So Solana is currently at 300. So if we go back to our scenario builder, what we can do is click on that, the scenarios, and here we can just start it once again. If we go through these prices, just as what we do here, as you can see, we can change that price and our bot, it will pick it up. As you can see here, the price dropped by 39%. So we're going to buy SOL, we're getting that quote, we're getting these swap instructions, and then we're signing and sending the transaction locally. And this is our transaction. And again, also the price rose once again. So we're getting that quote, the instructions, we're signing and sending the transaction. Once again, what we can do is change the price. So we can also go through these and we can just let our bot do its thing. And that's how we actually test our logic now. So once again, we can go through these prices because we know every 1 second our bot fetches that price and then we'll do the swap. Now we went through all the steps. So if we go back to our bot, you can see it has been doing exactly what it needs to do. Selling SOL, buying SOL, selling SOL, and all these transactions, they are locally. So if we go back to Surfpool, if we close this here now, if we go to console, and we can really inspect all these transactions. So if we look at the last transaction, you can see all the instructions that take part of this swap, and then we can go through each instruction and actually checking what's happening. We can see how many CUs it consumes, how many accounts are involved. We can also inspect it using the Explorer. However, we can really go through these instructions and we can see when there are account updates, how many LAMP ports are changed. So here you can see that the LAMP port changed from 16.5 to 16.5 and a bit, and we can go through all these instructions and see what's going on. The same thing if a transaction fails, as you can see here, this fails, it will also output it. We can see what's going on. So it failed in this instruction here. So we get a custom program error, and then we can look up what that custom program error actually means. This can be slippage or something else that went wrong. However, we can use Surfpool to go deep into these transactions and see what's actually happening. More important, if we look back at our wallet, we can see now that we have 16 SOL and about 85 USDC left. So it's hard to say if our strategy is really profitable. We need to have more tests, of course, but I hope that you understand that this setup is really powerful and that Surfpool provides us a lot of features that we can use to test our trading strategies using actual mainnet live data. And that's what we did here. So first of all, we created a wallet where we can airdrop these tokens, not only Solana, but a range of different tokens that we can use within our trading bot. Then we set up these scenarios to manipulate the price and feed that price into our trading bot. And eventually we can use these accounts that live on Mainnet, like for example, the Jupiter V6 swap accounts, to perform these swaps, build these transactions and land them locally instead of on Mainnet. And of course, we can also start investigating all the transactions and see what's going on here and optimize our transactions also in order to test our bot. So I hope now that you understand how powerful this setup is. Again, as a reminder, all the code is available. So if you want to test it out yourself, go to our GitHub, start your local validator, and you can do the exact same steps. That's it for today. I hope you think it was interesting, and I'll see you in the next one.